What'd you say, Gertie? Gertie says nothing. Oh, she's checking out the math. She says, how do I do that? What happens at a local min and what happens at a local max? What this is all about is we know that at a max or a min, f prime is equal to 0, but just because f prime is equal to 0 doesn't mean there has to be a max or a min. So let's talk about what happens at a max or a min. So what could a local min look like? So there are a lot of different ways it could look. Here's your classic local min, right? Oh, you know what I forgot? I forgot this. So before, I'm going to keep the cat intro though, so I'm just going to keep going. Before I start on that, here, look, it's calculus. It might be November 13th. I don't know what day it's going to eventually be when this shows. But we're starting chapter 4, and this is 4.1. Our first section is called extreme values. Extreme values of functions. So a lot of different kinds of functions. We're interested in the maximum and minimum. So here's the kind of vocabulary we're going to use. Some of this might be a little bit unfamiliar. For example, if I have one maximum, the plural is maxima. How many maxima does this function have? Find all of the maxima. All right. This function has one minimum. It might have more than one. It might have several minima. All right, and so either a maximum or a minimum. Sometimes we want to say have a single word that refers to a max or a min. So that's called an extremum. So we use extremum to refer to any extreme value of the function. So then, of course, the plural is extrema. So these are vocabularies that we're going to use. The extrema may be local or global. We also use the words relative and absolute. So local and relative mean the exact same thing. Global and absolute mean the exact same thing, but these two are opposite. So relative means I'm the biggest fish in my local pond. However, there are bigger fish elsewhere. All right. Absolute means I'm the min, and there is no one anywhere in all of the real numbers whose value is lower than mine. For all of the real numbers, okay? So that's the difference between local, relative, global, absolute. Remember, local and relative mean the same thing. Global and absolute mean the same thing. Okay, now, so now that we know what a local min is, you probably already knew that. I just wanted to go over the vocabulary. What can happen there, okay? So you could have something like this. And what you can see there is that the function is going to have a horizontal tangent. But could a function have a min without having a horizontal tangent? Why, yes, it could. The function could have a cusp. That's why these are so important. A non-differentiable point. Now, this is still a min, but we can't draw a tangent to it, right? In fact, one of the ways to understand that a cusp is non-differentiable is you could draw many different lines that are tangent to the curve that only touch the curve at one point. Therefore, there is no unique tangent. The tangent is not well defined. That's one way to understand why these cusps do not have a derivative. Okay. You could also just have a nice absolute value-y corner, which is really sort of the same thing as that. These are all mins. So you have either a horizontal tangent or a non-differentiable point. So we have either a horizontal tangent or you have a non-differentiable point. All right. What happens at a local max? All right. So you could have your standard max. You could have a cuspy max. You could have an absolute value-y max. All right. And you have the same kind of things. Either we're going to have a horizontal tangent or you're going to have a non-differentiable point. Okay. And so if I have a horizontal tangent, then that means that f prime of x equals 0. And if I have a non-differentiable point, that means f prime of x is undefined. All right. If I have a horizontal tangent, again, f prime of x equals 0. And if I have a non-differentiable point, f prime of x is undefined. So when I have a max or a min, so if f has a max or a min, then f prime has to be 0 or undefined. So this condition where f prime is 0 or undefined, we call this a critical point. We say f has a critical point. So a critical point we're going to define to be a point where f prime of c equals 0 or f prime of c is undefined. So in either of those cases, we call that a critical point of f, when f prime of c is 0 or f prime of c is undefined. So here's what we know so far. If f has a max or a min, then f prime has to be 0 or undefined. But if f prime is 0, so let's say it this way. If f has a critical point, does f have to have a max or min? The unfortunate answer is no, because consider f of x equals x cubed, all right? So f prime of x is 3x squared, and then in particular f prime of 0 is 3 times 0 squared, which is 0. All right, but what is f of x actually doing when x equals 0? So here's what f of x equals x squared looks like. All right, that's f of x equals x cubed, right? So f has a critical point, a horizontal tangent, but does f have a max or min? No. So at x equals 0, f of x has a critical point, but no max or min. All right, what about the critical points where f prime is undefined? So consider f of x equals cube root of x, all right, also known as x to the 1/3 power. So what's f prime of x? It's 1/3 x to the negative 2/3, which equals 1 over 3 cube root of x squared. So this is never going to be equal to 0 because the numerator is 1. However, this is undefined. F prime of x is undefined at x equals 0 because the denominator would be 0. All right. What's going on at that critical point, x equals 0? Well, here's what f of x looks like. This is the graph of cube root of x. It's your classic vertical tangent. All right, so f has a vertical tangent here. That vertical tangent is the reason why f prime of x is undefined. Okay, so again, at x equals 0, f of x has a critical point, but no max or min. All right, so our conclusion so far is that if f has max or min, then f has a critical point. But this implication is unidirectional. It only goes one way. We cannot conclude that because f has a critical point, it has a max or min. In fact, we could write that like this. F has a critical point does not imply that f has max or min. So, how are we going to use that information to find the maximum and minimum values of functions? Stay tuned.